Hello students, welcome to lecture 4 of chemical equilibrium. I will start with recap which I did in the last lecture, that is in the last lecture I discussed about Le-Chatelier's principle. The most important use of Le-Chatelier's principle is we can know under what condition a reaction can give maximum product or reaction can give maximum yield. What do I mean by condition? We can change concentration, we can change pressure, we can change volume and we can change temperature. So, if we understand Le-Chatelier's principle, we will be able to tell if I increase the temperature whether reaction will go to right hand side, means more product will be formed or less product will be formed. Similarly, if I increase the pressure, then what will happen to the reaction, whether reaction will shift towards forward direction or reaction will shift towards reverse direction. What Le-Chatelier principle tells you? It tells you that if we alter the conditions, for example, pressure, temperature or volume, we can disturb the equilibrium. Finally, a new equilibrium will be established. This principle tells you that new equilibrium will be in which direction, whether equilibrium will shift to right hand side or left hand side. The law tells you that equilibrium will shift to that direction which tends to minimize the change. Equilibrium will shift to that direction which tends to minimize the change. Then we looked at the effect of increase in pressure. So, suppose I am increasing the pressure, that can be done by decreasing the volume. Okay. I showed you that in that case if delta n is positive, reaction will move towards reverse direction or reverse reaction will be favored. What I mean by delta n is your change in stoichiometry. So, basically it is the stoichiometry of product minus stoichiometry of reactant. If this is positive, then reverse reaction will be favored. If it is negative, then forward reaction will be favored when we increase the pressure. So, this is about when I increase the pressure. So, if reaction has delta n is positive, increase in pressure will favor the reverse reaction, whereas if delta n is negative, increase in pressure will favor forward reaction. Pressure can be changed in another way. Pressure can be changed by introducing your inert gas. So, first condition we discussed that when we change pressure by decreasing the volume or increasing the volume, pressure will be increased if we decrease the volume, whereas pressure will decrease when we increase the volume. But we can increase the volume, we can increase the pressure by introducing inert gas, keeping volume constant. So, suppose I am taking a closed container and then we have molecules of A and B. A is your reactant, B is product. I can increase the pressure by introducing another gas which does not interact with A or B. which does not interact with A and B, and that is basically you are introducing inert gas. Overall pressure is increased, volume has not increased. Okay. In that case, what happens? So, I discussed this reaction PCl5 gas giving you PCl3 gas plus Cl2 gas, Cl2 gas. In this case, Kp can be written as pressure of PCl3 into pressure of Cl2 divided by pressure of PCl5, and pressure is your mole fraction of PCl3 multiplied by total pressure into mole fraction of Cl2 multiplied by total pressure divided by mole fraction of PCl5 into total pressure. And then this can be written, and mole fraction can be written as N of PCl3 divided by Nt, where Nt is total amount of gas, total number of gaseous molecule. This not only includes reactant and product, but also includes inert gas. So, Nt multiplied by NCl2 divided by Nt into P. This is also into P, okay, divided by again NPCl5 by Nt into P. 1 P cancels out, 1 Nt cancels out. So, what we are left with NPCl3 into NCl2 divided by NPCl5, okay, and then one pressure left this side, pressure by Nt. So, now you see you have this quantity, and Kp, the direction will depend on whether P by Nt is increasing or decreasing. If it increases, then what will happen? This value will decrease to keep Kp constant, while if this decreases, this will increase to keep Kp constant. So, what happens? You see P by Nt, I told you that reaction was carried out in closed container. What does that mean is, you have a constant volume condition. Under constant volume and temperature, your P by Nt is constant, P by Nt is constant, and so basically this does not changes, and so there is no need for change in this quantity. What does that mean is that introduction of inert gas will not have an effect on a reaction. If pressure is increased by addition of inert gas at constant volume. So, in a closed container, which means constant volume system, introduction of inert gas does not have effect on the reaction, even if there is increase in pressure. But suppose if I carry out reaction which has a cylinder, which is like piston, okay, and then you have reactant, you have product. And now what you did is you increase the volume such that if I introduce inert gas, the pressure is constant, total pressure is constant, but volume changes, a volume increased, volume changes. Okay. So, this volume is greater than, so this is V 2, if suppose volume is this is V 1, V 2 is greater than V 1, and introduction of inert gas does not increase the pressure, is kept constant. In that case, what will happen? So, let us again discuss this reaction. PCl5 gas going to PCl3 gas plus Cl2 gas. Okay, so, Kp is equal to your again pressure of PCl3 multiplied by pressure of Cl2 by pressure of PCl5, and this is mole fraction, means N of PCl3 by Nt multiplied by total pressure into NCl2 by Nt into total pressure divided by N PCl5 by Nt into total pressure. One pressure cancels out, Nt, one Nt cancels out. So, this is basically this NPCl3 into NCl2 divided by NPCl5 and multiplied by your P by Nt. Now, you see this P is constant and your Nt is changing. Nt increased because you introduce the inert gas. If you introduce the inert gas and Nt is changing, since Nt is in denominator, basically increase in Nt means P by Nt is decreasing, P by Nt decreased. So, this must increase to compensate for your Kp. To keep Kp constant, this value should increase since P by Nt is smaller, P by Nt is smaller. When that will increase? This will only increase when your NPCl3 or NPCl3 and NCl2 will increase. It means reaction goes towards forward direction, So, if Nt is delta N is, where delta N is your difference between your stoichiometry of product minus stoichiometry of reactant. If this is positive, as in case of your PCl5 going to PCl3 plus Cl2, your introduction of inert gas at constant pressure will shift the reaction to forward direction. So, this is about effect of inert gas. Inert gas will change the pressure, inert gas may not change the pressure. So, the shift in reaction will depend on under what condition you are carrying out the reaction. Okay. So, now pressure volume is done, what we will do is we will go to temperature, effect of temperature, effect of temperature on equilibrium. Effect of temperature on equilibrium. So, effect of temperature will depend on whether reaction is effect of temperature will depend on whether reaction is exothermic or endothermic. If reaction is your exothermic, if reaction is exothermic, so basically delta H is your negative. What does this mean? Exothermic means A plus B giving you C plus D and heat is released, plus heat released. In this case, if I increase the temperature, if we increase the temperature, reaction will shift towards that side, the reaction will shift to the direction where heat is absorbed, Since in exothermic heat is released, so heat is absorbed for a reverse reaction. So, if I increase the temperature, the reaction will shift towards your reverse direction. So, basically exothermic reactions are favored at low temperature. If I take a reaction which is endothermic, it means your heat is absorbed. Delta H is your greater than 0. So, it is positive. In this case, if I increase the temperature, if we increase the temperature, forward reaction will be favored. Since in the forward reaction heat is absorbed, favored. Now, let us understand what happens to Kp. With temperature. Before that, we told that Kp does not change with number of moles of pressure. pressure or volume. But Kp depends on temperature. Kp depends on temperature. Kp depends on temperature. The equation which governs the effect of your temperature, the equation which governs effect of temperature on Kp or Kc is given by del log K P by del T at constant pressure is equal to delta H naught by R T square. Okay. So, Kp will depend on the temperature dependence of Kp will depend on delta H naught. So, if I take endothermic reaction, your Kp increases with increase in temperature. While Kp for exothermic reaction Kp decreases with increase in temperature. Kp decreases means your product will decrease and reactant will increase. And that means is that reverse reaction is favored. So, in summary, your exothermic reactions are favored at low temperatures, whereas endothermic reactions are favored at high temperature. Now, let us take some example and see what happens when we increase the temperature. So, effect of temperature. So, first reaction is your SO2 gas plus O2 gas giving you SO3 gas. So, when SO2 reacts with O2 to give SO3, your heat is released. And it is an exothermic reaction, and delta H is equal to minus 180 kilojoule. Delta H is equal to minus 180 kilojoule per mole. Since this is a exothermic reaction, if I want to increase the product, what should we do? We should go to low temperature, we should decrease the temperature, because exothermic reactions are favored by your are favored at low temperature. So, if we want higher yield of SO3, we should decrease the temperature. Now, let us take dissociation of N2O4. The second reaction is dissociation of N2O4. So, N2O4 gas dissociating to 2 NO2 gas. Okay. N2O4 dissociating to NO2 gas. In this case, your reaction is basically endothermic. It means that heat is absorbed during the process. Delta H is positive. So, if we want more dissociation, we have to increase the temperature. Because endothermic reactions are your favored at high temperature. You can think about several different cases. For example, methanol production, CO gas plus 2H2 gas giving you CH3 OH gas, and delta H naught is equal to minus 270 kilojoule per mole. Now, again you see this. To know the effect of temperature on a reaction, we must know whether the reaction is happening with release of heat or absorption of heat. In this case, heat is released, and so this reaction will be favored at low temperature. Means if we decrease the temperature, we can expect to get higher amount of methanol. Now, we can use it in a opposite sense also. So, suppose a reaction A plus B going to C plus D, let us take this in gaseous form. Okay. If we know that with increase in temperature, product is increasing. That will give you clue about whether heat is absorbed or released in a reaction. Since product is favored, when I increase the temperature, it means that heat must have been absorbed in the system or absorbed during the reaction. What does that mean is that your reaction is endothermic reaction. So, reaction is endothermic. reaction is endothermic. On the other hand, I get with increase in temperature, the amount of product decreased. Then we can simply say that your reaction is exothermic. So, just by looking at reactant and product, how much they increased when we increase the temperature, we can tell whether a reaction is endothermic or exothermic, heat is absorbed or released. So, we just saw the effect of concentration, pressure, inert gas and temperature on the equilibria. Now, we know what will happen if I increase the temperature, if I increase the pressure, if I introduce the inert gas, and we can know in which direction reaction will shift, and that can be applied if I want to increase the product, if we want to increase the product. So, this information will help you whenever you are trying to carry out a synthesis. So, let us go and see some more examples. For example, let us take this case H2 plus I2, H2 gas plus I2 gas, giving you 2 HI gas. Now, suppose I want to know the effect of your pressure, effect of pressure. So, must remember that last time I did showed you what will happen when we alter the condition. So, see this, I just want to show you that we discussed what will be the effect of increase in pressure. If delta n is positive, a reverse reaction will be favored with increase in pressure, whereas if delta n is negative, then forward reaction will be favored with increase in pressure. Now, let us see what is delta n here. So, delta n is your, you see this case 2 moles of HI. So, 2, this is the product minus reactant. Reactant is what? 1 plus 1. So, this is 0. So, what does that mean is pressure will not affect the reaction. If suppose we increase the volume to double, pressure will decrease, but since del n is 0, so even the effect, there will no effect of increasing or decreasing the volume, no effect of inert gas either, even at constant pressure, since del n is 0. Only thing which can affect this reaction is temperature. So, if it is an endothermic reaction, the effect of temperature will be different, and if it is exothermic, effect of temperature will be different. Now, let us take another example. 4 NH3 gas plus 5 O2 gas, giving you 4 NO gas plus 6 H2O gas. So, let us see whether it is balanced or not. 4 nitrogen, 12 hydrogen, 10 oxygen, 4 oxygen plus 6 oxygen, your 10 oxygen. So, this is your balance equation, and we want to see the effect of pressure, volume, inert gas or temperature. So, let us see delta n. First we have to calculate delta n. Delta n is your stoichiometry of product. So, 4 plus 6 10 minus 4 plus 5 9 is equal to 1. So, it is positive, it is greater than 0. It means there will be effect of pressure, there will be effect of pressure. Here delta n is your delta n is positive, and that means that if I increase the pressure, reverse reaction will be favored. Reverse reaction will be favored. If I increase the volume, pressure will decrease, and your forward reaction will be favored. So, if I increase the pressure, reverse reaction will be favored. If I increase the volume, your forward reaction will be favored. Effect of inert gas, if I keep volume constant, if we are doing it in a closed container, then there will be no effect. But if we take the case of constant pressure, I introduced inert gas such that pressure is constant. In that case, your forward reaction will be favored. Now, suppose take S2 plus Cl2 gas, this is your SCl, 2 SCl plus 92 kilojoule, 92 kilojoule. If suppose this is given. Okay. Now, let us think of what is the effect of pressure, temperature and volume. What is the effect of pressure, temperature and volume? Now, you see this, that your 92 kilojoule of heat is released. So, this is your exothermic reaction. In that case, temperature will have effect. What about pressure and volume? For pressure, so looking at effect of pressure of volume at equilibrium, we must calculate delta n, and delta n is your 2 minus 1 plus 1, which is 0. What does that mean is, increase or decrease in pressure will not affect this reaction, all are in gaseous phase, Okay. But introduction of inert gas will also not affect this reaction, whether it is carried out at constant volume or constant pressure. Only thing which is going to affect this reaction is your temperature, and since this is a exothermic reaction, your temperature, increase in temperature will not favor the reaction. Basically, a low temperature will favor the reaction. Now, take another case, S2 gas plus I2 gas giving you 2 HI gas, and delta H is equal to 25 kilojoule. This is plus kilojoule. What does that mean is, the reaction is your endothermic. So, suppose if we are trying to look at effect of pressure or volume, first we calculated delta n, and delta n here is 2 minus 1 of H2 and 1 of I2, and so this is 0. So, no effect of pressure or volume, no effect of pressure or volume. What about others? No effect of inert gas. Inert gas. What about temperature? Temperature will affect, because this is an endothermic reaction, and endothermic reaction are favored at high temperature. So, high temperature will increase the product, which is Hi in this case, Another reaction, 2NO2 gas giving you N2O4, and this is your delta H is negative. What does that mean? This is exothermic reaction. Now, we can see that this is also in gaseous form. What is delta N? Delta N is 1 minus 2, which is minus 1. It means pressure volume will affect. If I increase the pressure, first thing increase the pressure, what will happen? If I increase the pressure, you see this is the minus 1. Okay? So, forward reaction will be favored. If I increase the volume, reverse reaction will be favored. If I increase the temperature, now you see this is exothermic reaction, and in exothermic reaction exothermic reactions are not favored at high temperature, they are favored at low temperature. So, reverse reaction in this case will happen, will be favored. Another way to remember is that increasing the temperature will shift the reaction toward that side in which heat is absorbed. So, if I take the reverse reaction, in this case your delta H will be positive or heat will be absorbed. So, dissociation of N2O4 is an endothermic reaction, and so with increase in temperature reverse reaction, this dissociation will be favored. Okay. Inert gas, effect of inert gas at constant volume it will not affect, but at constant pressure your reaction can be affected. It will just opposite to this. In this case your reverse reaction will be favored. Now, last is the effect of your catalyst, effect of catalyst. What will happen? So, effect of catalyst on the equilibrium. Okay. So, what happens when I add the catalyst? We know this is the potential energy or energy versus reaction coordinate. Okay. This is kind of shape we get. This is your reactant, this is your product, and this is transition state. This is the transition. So, if we have a reaction and if we do add catalyst, what can happen? We know that if I add a catalyst, so in presence of catalyst, this curve will be something like this. What does that mean? Reactant and this is product and this is transition state. So, catalyst basically stabilizes the transition state. So, it went down from this point to this point. So, reaction activation energy decreased, activation energy decreased. So, reaction will be faster, but does it affect equilibrium? Okay. Question is, does it affect equilibrium? Catalyst does not affect equilibrium. Does not affect equilibrium, because you see what is your K? K is your Kf by Kb. Kf is your rate constant for forward direction and Kb is rate constant for backward direction. Kf Kb changes when we add a catalyst, but the ratio does not change. Okay. So, Kf changes because activation energy will be lowered, and if activation energy for forward reaction is lowered, it means Kf will increase, but catalyst also decreases activation energy of reverse reaction, and so Kf also increases. So, Kf changes, there is increase in Kb and increase in Kf, but the ratio remains constant. Kf by Kb remains constant, and that means that there is no effect of catalyst on the equilibrium. You can understand this from here. So, what happens that you have energy versus reaction coordinates or extent of reaction. You have this kind of curve when there is no catalyst, and this is activation energy for forward reaction, this is activation energy of reverse reaction or backward reaction. When I add a catalyst, what I get is basically so it is initially, suppose this way, it goes down, the presence of catalyst. So, initially you have this is EAF, activation energy of forward, but in presence of catalyst it decreases to this. So, this is EA dash F. But you see activation energy of reverse reaction also decrease, activation energy of reverse reaction also decrease. So, it was here first. So, this is suppose EA for a reverse reaction, and now in presence of catalyst this is decreased to this value, and when this decrease to this value we have a new EAR which is called EA dash R. Okay. So, your equilibrium constant is this is Kf by Kb. Kf gets affected in presence of catalyst and it becomes Kf dash, and Kb also changes and that becomes Kb dash, but the value of Kf by Kb and Kf dash by Kb will remain same. So, catalyst increases the rate of reaction, it increases the rate of both reaction forward and reverse direction or reverse reaction, but the ratio of Kf and Kb does not change. So, ratio of Kf and Kb does not change. And so, catalyst does not affect the equilibrium, does not affect the equilibrium. So, in a nutshell, we can change the direction of, we can control a reaction by changing conditions, by changing conditions. We can maximize the product, if we have understanding of Lee-Chatelier's principle, and that is why Lee-Chatelier principle is very important when we are dealing with a chemical reaction. Thank you very much.